Hello, grade 10s. Well, congratulations. We're going to make it to the end of the unit today. So it says 3.8b. So the last 2 days we've been working on perfect square trinomials, and today we're going to work on difference of squares, and these are what sometimes are referred to as factoring special cases. So if you see that phrase on a worksheet or in a book, that's just what that means, is just this type of factoring. Okay, so a difference in the word math means subtract, so that makes sense. So a difference of squares has the following characteristics. It is a binomial, so there's only two terms in it. So if you see a trinomial, you know that there's no way that can be a difference of squares, even if there's a subtraction sign. It has to be two terms. The terms are separated by a minus sign, which is also called difference, right? Okay, and each term is a perfect square. I find these ones kind of fun to do. Okay, and I'm going to just show you the background here for a minute. There's a reason why it's called a difference of squares, and that is because the signs are different. And what happens there is they negate a middle term, and that's how you end up with a binomial. So we're going to work through some of these, and I'm going to get you the answer, and then we're going to work backwards, so like we kind of did in grade 9, and a few days ago I had you practice squaring binomials, and I'm just going to show you what happens here. Okay, so does this fit the characteristics of a difference of squares? It has two terms. Yes, it does. The terms are separated by a subtraction sign. Yes, they are. Is each term a perfect square? Yes. Okay, so this is how we do it. We can find the square root of x squared, which is x. We find the square root of 25, which is 5. We make 1 a plus, and we make 1 a subtraction. So when you're doing perfect square trinomials, you had two factors that were exactly the same, but I'm going to show you why it's important that these are opposite signs. So if we did the distribution, we'd get x squared minus 5x plus 5x, and then a positive times a negative is negative 25. And you see what happens? Those two terms cancel each other out. Okay, and we're left with x squared minus 25, which is back to the original answer. So if we had x plus 5 times x plus 5, we'd end up with x squared, okay, and then plus 10x plus 25. So we're going to end up with that middle term always. So that's why these signs have to be opposite, so they cancel out that middle term, and we end up with a binomial at the end. Okay, so here we go. Two terms separated by a subtraction sign, perfect square, perfect square. So we find the square root of the first term, which is p, square root of the second term, which is 8. We make 1 a negative and 1 a positive. So I did it different from the first one just to show you it doesn't matter if the negative comes in the first factor or if the negative comes in the second factor, as long as they're both opposite. And that's your final answer. It's that simple. Okay, so this one's not in descending order, but it doesn't matter. It works. Two terms separated by a subtraction sign, perfect square, and then we get 5 minus 6x and 5 plus 6x. There we go. Okay, now this one is here. Okay, remember I always like to give you every example. Even though these are perfect squares, both of them, we can see that they're both an even number, so we needed to take out a common factor first. So the greatest common factor of 4y squared and negative 100 is a 4. And you're left with y squared minus 25. Now, if we were still at the beginning of this unit, that would be completed. You would have taken out the greatest common factor, but now we've learned all the types of factoring. We know that we always have to look, see if there's another type of factoring we can still do. And indeed, this satisfies all the characteristics of a difference of squares. So we're going to have that greatest common factor out front, and now we are going to factor this as difference of squares. So the square root of y squared is y, square root of 25 is 5. We're going to make one of those factors positive and one of them negative, and now that is a complete answer. Okay, so now here, looks like it might be a difference of squares, except that 5 and 80 are not perfect squares. And then you think to yourself, is there something I can do? Well, 5 and 80 have a greatest common factor, 5, and you're left with x to the power of 4 minus 16y to the power of 4. And this is something new as well. Okay, we're used to working with x squareds and y squareds. Well, x to the power of 4, as long as this is even, we can find the square root of that. So we're going to write down our greatest common factor. The square root of x to the power of 4 is x squared. X squared times x squared, remember we add the exponents, we get back to x to the power of 4, minus 4y squared. I made this one negative, therefore the second factor has to be positive. and that's done. All right, now if we did a U try here, okay, but we're gonna do them together because we're not in the same room, because I would have had you do them and then I would have stopped you and then we would have done them together and checked our work. Square root of 81m squared is 9m. Square root of 49 is 7. I make one negative and I make one positive. Okay, so we're at the end of the unit and you don't have to overthink it. I know the decomposition was tough and this is a little bit easier. Okay, square root of 25 is 5. Square root of 36x squared is going to be 6x. I made one negative and I make one positive. Doesn't matter which order. Okay, positive could have been here, negative here. Now, 8. That's not working. But if you know your times tables well, you know that we can take out a greatest common factor. And that greatest common factor would actually be 8. X squared minus, and 72 divided by 8 is 9. And lo and behold, now we're back at two perfect squares. It's a binomial separated by a minus sign, so we know we can continue factoring. Square root of x squared is x. Square root of 9y squared is 3y. I made this one negative, therefore I'll make the second one positive. Okay, I'm going to stop there. And I know if you take a look in your notes, you're going to say, well, Mrs. Rosso, you skipped a whole page. Well, we're going to come back to that tomorrow, okay? That's not really a big deal. It's just sort of wrapping everything up, but it's stuff that you can cope with for sure. I'm going to post an assignment, okay, on finding or factoring difference of squares. Okay, take care.